Everyone, hope you're doing well. I'm going to go over the second part of yesterday's worksheet, Area of Irregular Figures. So I'm going to go through questions 6, 8, and 9. Number 7 you'll be submitting through Google Forms. Okay, so for number 6, we're trying to find the area of this irregular polygon over here. If you take a look, it did already drop down this auxiliary line, forming a little right triangle. I labeled that right triangle 3. My other 2 polygons was this rectangle over here, and then I had this square that was formed right in the center at 2. So I went ahead and I said, well, if I have all this information, I can now start to highlight and say if this is my rectangle, it has a height of 1.5 and a base of 3.5. So I know that for the area of that first rectangle, it's going to be 3.5 times 1.5, which is 5.25. Then over here for the second shape, it has a base of 5.5. And I got that by saying, well, this entire side is 9 units, okay? And I know if this is a horizontal length, I look up here and I see that this piece is 1.5, this is 3.5, and this is 0.5. If I add all 3 of those values together, I get 5.5. So that means that this piece is 5.5. The whole thing is 9, so 9 minus 5.5 is 3.5. So that's how I got this dimension, this base. And then going back, if this base is 5.5 and the height was given at also 5.5, then there's the area, 5.5 times 5.5, which is 30.25. And last but not least, I have over here a triangle, which is base times height divided by 2. So 3.5 times 4.0 divided by 2, which gives us 7. So I add all 3 of those areas together, and the sum is then 42.5 units squared, right? Just said units, it didn't specify whether it was centimeters, inches, millimeters, so on and so forth. Okay, so there was number 6. Okay, number 7, you're going to find the area of the shaded region, and you'll be submitting your answer on Google Form. So something you may want to consider is thinking about area of the big minus the area of the 2 smaller figures. Okay, so the area of the big is a triangle. You would take away the 2 smaller figures, the rectangle here and the rectangle here. Okay, so it's just a thought for you. A lot of you have been submitting your work, and I just want to remind you, you're not being graded in terms of it being correct or incorrect. It's merely just a way for Mr. Bronze and myself to say, hey, okay, so-and-so tried out the lesson today. We're happy to see it. You guys are doing a really good job, and I really do appreciate you taking the time out to kind of watch the videos, try these questions, and submit something. We do appreciate it, so keep up the good work. Okay, so to finish the next 2 questions on this worksheet, number 8 was a little different, but I think it's definitely something you'd be able to do based on our knowledge of regular hexagons or regular polygons in general. So a regular hexagon means it has 6 equal sides. So if each side is 8 inches and we had to find the perimeter, essentially we just add up all 6 sides at 8 inches to give us 48, or 6 times 8. Quicker way to add 6 times to give us 48 inches. Okay, remember perimeter is one-dimensional, so it's just inches. Now the next part was a little tricky. I have here, it's a challenge, and it definitely is. So what you need to remember about a regular hexagon, and this goes back to constructions. A regular hexagon is actually made up of 6 equilateral triangles. Okay, so one regular hexagon has 6 equilateral triangles in it. So think of it like this too. So like up here would be like a regular hexagon. Now I sketched this one, so it's not perfect. So that means that all these sides are all the same. So they're all 8. So what does that mean? How does that then help us? Well, here's the thing. There is no formula for area of a hexagon. I mean, there is, but we're not going to be dealing with it. We're going to use dissection, because to memorize another formula is just silly. I guarantee you right now, if I say what's the area of a triangle, majority of you would be able to say, well, it's base times height divided by 2. So let's just use that idea of base times height divided by 2. Because if I can find the area of just this triangle, Then I multiply it by 6, and it counts for then the entire figure, which is a hexagon. Okay, so I take a look at this triangle, and I say, well, in this triangle, I have a base right here of 8. But notice I split it up to 4 and 4. And I did that because I drew in this altitude. And because this is an equilateral triangle, I know once I draw in the altitude, it divides the base into 2 equal parts, and it becomes perpendicular as well. Well, once that happens, I now actually have formed a right triangle. Here's the base, here's the height, there's the hypotenuse. So we're going to use Pythagorean theorem to find the height of this triangle. So let's take a look. I have my h, my base of 4, and my hypotenuse, my c, which is 8. So a squared plus b squared equals c squared. I substitute in all my information. I get h squared by itself, and I get h squared equals 48. Take the square root. Now here's the other thing. It wants the nearest integer. So I'm not even going to round this. We know if I take the square root of 48, it's an irrational, messy number. I chose to just break it down in my calculator to 4 radical 3. By all means, you could leave it as radical 48. That's completely fine. What you don't want to do is round that number to the nearest integer. If you want to round it to nearest thousandth, that's okay. I suggest just leaving it as either radical 48 or 4 radical 3. So now I have all the information I need to use my formula. Here's the height at 4 radical 3, and my base is 8. So I'm like, all right, well then one triangle must be 8, the height, the base, times 4 radical 3, the height, divided by 2. Okay, so then I just showed you how I kind of broke this down. 8 times 4 is 32, times radical 3 divided by 2. Remember, when you divide with radicals, you can only divide the coefficient by 2. So half of 32 is 16. So I have 16 radical 3 is one triangle. Now we have 6 equal triangles. So if one triangle is 6 radical 13, well, all of them are. So I'm going to do 6 times 6 radical 13. 6 times 16 radical 13. So 6 times 16 is 96. So we have 96 radical 13. And now I do need the nearest integer, nearest whole number. So that's the output in the calculator. Round that to nearest whole number, and I get 166 square inches. All right. So again, a little challenging in terms of just recognizing that it's 6 equilateral triangles within this hexagon. But really from there, we're good with Pythagorean theorem. We're good with the area of a triangle. I do admit I think dealing with radicals can be a little tricky at times, but I think you're more than capable of kind of handling something like this. And even if you want to deal with the decimals, that's fine too. Okay? So again, irregular figure, not so much, but kind of in terms of it doesn't have a defined formula, so it does fall into this category of an irregular figure. Okay? And then the last question was pretty straightforward, right? It just said that we had a perimeter of a pentagon. Remember, pentagon is 5 sides, is 120 inches. We first were told 4 sides measure 24.5 inches, 18.2 inches, 32.6 inches, and 16.1 inches. Find the length of the 5th side. So I wrote myself a little equation. I took the 4 known sides plus the unknown side x, and I said equal to 120. Did some quick algebra, combined like terms, subtracted 91.4 from 120, got x, that 5th side, to be valued at 28.6 inches. Okay, and that was that one. And last but not least, number 5, B, if the pentagon, which is regular, 5 equal sides, if the pentagon, is regular, what is the length of its side? So if this pentagon that they're talking about that has a perimeter of 120 inches is a regular pentagon, what's the length of one side? So for this, think about it. There's 5 equal sides. The perimeter is 120. What would I do? And if you're thinking and not quite sure, well, I'd say, well, if my perimeter is 120 and all 5 sides are the same, I would just divide. So one side length is 24 inches. Okay, and that was that one. Okay, So that does finish up the worksheet for this week. Tomorrow is Friday, so your work is going to be just to check over your notes, kind of look through the answer keys, make sure that any questions you reach out to us, and we'd be more than happy to answer them for you. We might put up a informal Google form just to kind of get some more feedback, see how you guys are doing out there. We do hope you're doing well and staying healthy and trying to stay busy with, remembering to social distance yourself and all of those crazy things that we never thought we'd be doing in a time like today. Before I go, I just want to remind you to go back to number 7, right, area of the shaded region, and submit this answer through Google Form. Remember, area of the big figure, which is a triangle, and take away from it the area of the 2 smaller figures here and here. Okay? Good luck, and I will be posting another video either for Friday or next Monday. Okay, take care.